The final homework for this week is special factoring situations. And I just want to talk to you a little bit before we get started on this. Remember yesterday when we talked about factoring, one of the most important things to remember is finding a greatest common factor. So if you had 2x squared minus 8x plus 12, the very first thing that you would have to do is factor out the common factor of 2. And then the remaining factors are grouped together as a sum and a difference. And then you have to figure out what are the factors of positive 6 that when added together give you negative 4. Now, if I think of these factors, I've got 1 and 6. I've got 2 and 3. And I notice that this cannot be factored. So this is the factoring in simplest form. Now, the reason why I bring that up is your first card for today is factor by grouping. What you want to do when you factor by grouping is you factor a common monomial from pairs of terms looking for the binomial factors. All right, well, let's take a look. Mrs. Rose, when I look at this, I see something that's very apparent. Both of them have a factor of the difference of x minus 2. Well, what did we say yesterday? Greatest common factor, remove the greatest common factor. The greatest common factor is a binomial, and that's okay. Okay, I have factored that out. What is the remaining difference? 5x squared minus 3. Oh, what about this one? Mrs. Rose, you must have lost it because there isn't a common factor. There's not a common binomial. I can't do this one, Mrs. Rose. I just can't. Oh, as Lee Corso says, not so fast, my friends. Take a look at this and this. This is a positive 5. This is a negative 5. This is a positive y. This is a negative y. Oh, wait. Multiplication property of negative 1. Any quantity multiplied by negative 1 becomes the additive inverse. Oh, additive inverse of this, additive inverse of this. Hey, you know what I can do here? I can keep this 7y, and I can factor out a negative 1 and make each of these the additive inverse. Why, Mrs. Rose, you're so smart because you know what? When you do that, you now have exactly a binomial factor that they have in common. And what is the sum that is left? Well, 7y times negative 1 is negative 7y plus 3. There we go. Now, how did I do that again? Find the common binomial factor, factor it out, the remaining difference, or sum, in this case it's a difference, written as a factor. Go ahead and try this one. When you go to do this one, hint, 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 look at your notes from this slide. Now, what about factor by grouping? When you get into high school, you're going to do a whole lot more of this, okay? We're going to basically train our sights on qubits. And there are many, many ways to figure this out, but this is the one that works easiest for Mrs. Rose. The first thing she does is she groups the cube term and the square term, and she groups the single variable term and the constant. And then she says, hey, does this have a common factor? Of course it does. Y squared. What is the remaining sum? Y plus 7. Hey, do these have a common factor? Sure they do, Mrs. Rose. Positive 2. What is the remaining sum? Y plus 7. Hey, I have a common binomial factor. Y plus 7. I have a remaining sum. Y squared plus 2. I don't know how to factor y squared plus 2, so this is my polynomial in factored form. Let's try that again. All right. I'm going to group these because I see they have something in common. I have an x in common here. That would leave me with x plus y. I have a y in common here. That would leave me with y plus x. Hey, aren't these the same thing? Oh, yeah, they are. And the reason why they're the same thing is because I know commutative property. So, x plus y times x plus y. Oh, silly Mrs. Rose. When I have a factor multiplied by itself, it is that factor raised to the power of 2. Mrs. Rose, would you please do that again? Sure, no problem. Be happy to do it. But there's a problem here. Not written in standard form, correct? So let's write it in standard form. Let's group. Let's remove. Let's remove. Common binomial factor. Yeah, betcha. Remaining sum as a factor. As Regis Philbin says, that is my final answer. You go ahead and try this one. Don't forget, put it in standard form. You want me to do what? Yes, I do. Here's 4 questions. I want you to solve each of these by yourself tonight and be prepared to discuss them in class tomorrow. We're going to start class with this tomorrow, okay? Factor by grouping. See if you can factor it with common sense. Difference of perfect squares and greatest common factor. Greatest common factor and then factoring a trinomial. Remember, if you cannot factor it using those methods, your answer will be not factorable, but not used that often. So, do you need more help? Here's 2 websites you can go to get more help. You'll notice as we do a lot of these videos, virtualnerd.com is one of my favorite websites to use when I just need extra explanation, okay? He's very, very, very helpful. So if you need any help, pause the video right now and copy down these websites. Do I expect you to be an expert tomorrow? No, but I expect you to be prepared and get ready to rock and roll with factoring. Toodles for now. Have a great green and gold night.